welcome back to my channel. Today we're going to look at transition metal chemistry with a focus on naming and writing formula for complexes. First, let's look at some definitions. A transition metal complex is a compound made of a transition metal ion bonded covalently to ligands. A ligand is a molecule or negatively charged ion with a lone electron pair available for dative covalent bonding to a transition metal ion. Ligands can be classified according to the number of atoms that they use to bond to the transition metal ion. For example, a monodentate ligand would use one atom to bond, a bidentate ligand would use two atoms to bond, and a hexadentate ligand, such as EDTA, would use 6 atoms to bond. The coordination number is the number of bonds that is formed by the transition metal ion. A dative covalent bond is a covalent bond in which both shared electrons originate from the one atom in the bond. Here we have 3 transition metal complexes. In this first complex, we can see that the metal itself is forming 6 bonds. This means that the metal's coordination number is 6. If we look at the ligands, we can see what atoms they are using to bond. There is only one ligand, and it is using 6 different atoms to bond. This means that this is a hexadentate ligand. In this second example, we can see that the platinum is forming 4 bonds. This means that the metal's coordination number is 4. Each of the ligands is only using one atom to bond to the metal. This means that both types of ligands here are monodentate. In this iron example, we can see that the iron is forming 6 bonds. This means that the metal coordination number is 6. There are 3 ligands attached, and each ligand is using 2 atoms to join to the iron. This means that the ligands are bidentate ligands. Pause the video now, and for each complex, state the coordination number of the metal, and for each ligand, give its classification. In this iridium example, we can see that the metal is forming 6 bonds. Therefore, the metal's coordination number is 6. There are 3 ligands, and each of them is using 2 atoms to bond to the metal. This means that we have bidentate ligands. In this iron example, iron is forming 6 bonds. This means the metal coordination is 6. We can see that the ligand on the left and the right hand side is bonding through 2 atoms. This makes that a bidentate ligand. The hydrogen ligands are bonding through 1 atom and are therefore monodentate ligands. Ligands are given special names when they are in complexes. Here we have a look at the different ligand types and their formulas. We have anionic or negative charged ligands and neutral ligands with no charge. The halogens, such as chlorides, fluorides, bromides, have as their ligand formula their symbol with their negative charge. As a ligand, we need to change the end of the name from chloride to chlorido, bromide to bromido, and iodide to iodido. For oxygen, we change the name from oxide to oxido. Water is aqua. You'll notice that the ligand formula for water is OH2 rather than H2O. This is because the lone pair on the oxygen is used to form the dative covalent bond to the metal, and therefore this atom must go first. Ammonia is given the name amine, which has two M's, and spelling is very important. The lone pair on the nitrogen is used to form the dative covalent bond, and therefore the nitrogen goes first in the formula. Cyanide is given the name cyanidal. The carbon is the one that bonds to the transition metal and therefore goes first. Hydroxide is hydroxidal. And finally, carbon monoxide is carbonyl. There are specific rules that we need to follow when naming transition metal compounds. The first rule is one that you've been following for many years, and that is that the positive ion or the cation must go before the negative ion. For example, sodium chloride, where sodium would be a positive ion and chloride would be the negative ion. Now, one of these two ions will be a complex ion and will have a longer name. When naming the complex part, the ligands are named alphabetically before the metal ion. If you have multiple of the same ligand, then you need to use prefixes di and tri. If overall the complex is negatively charged, then the name of the metal ends in ate. The Latin name is used for some metals. For example, cuprate is used for copper and ferrate is used for iron. The charge of the transition metal is shown as a Roman numeral after the transition metal's name. Let's have a look at an example. Before we try to write out the name, we need to do some calculations first. We need to work out the charge of the complex. We can see here that we have two chloride anions as our counter ions. That means that we have a 2 negative charge here. So overall, the complex ion must be a 2 positive. Water is neutral, therefore the copper itself must be 2 positive. When we name this complex, the positive ion is going to go before the negative ion. The positive ion is our complex part. We need to name the ligands first. So the ligands that we have here are water ligands and they get called aqua. There are 6 of them, so we're going to have the prefix hexa, followed by the aqua. As the square brackets is positively charged overall, we get to keep this as copper. But we do need to put the charge in Roman numerals after. So that's 2. We can then put the counter ion afterwards, which will be chloride. Notice that in this section of the name here, there are no spaces between any of the parts. It is all one word. So the name is hexa aqua copper 2 chloride. Pause the video now and try to name these examples. Our first step is to calculate the charge of the complex. We have 2 fluoride counter ions as 2 negative, so the part in square brackets must be 2 positive. The amine ligands have no charge, therefore the 2 positive is on the cobalt itself. The ligands will be named first. There are 6 of them, and they are all amine ligands. Please be careful with spelling. We then have cobalt, and we can keep it as cobalt because the square bracket part is positively charged. We then have the charge of the cobalt, which is 2, followed by the counter ion, which is fluoride and is negative. So overall, we have hexaamine, cobalt 2, fluoride. The first step here is to calculate the charge of the square brackets. So we have 2 potassium ions, so that's 2 positive, which means that the square bracket itself must be 2 negative. The water ligands have no charge, but the cyanide ligands have a 1 minus charge each, so that is 4 minus. The metal must always be positively charged as it is a metal, so for overall the square brackets to be 2 minus, then the iron itself must be 2 positive. The name of the positive ion comes first, which is potassium. We then leave a space and we need to name the ligands first. They need to be named in alphabetical order. So the aqua will come before the cyanidal. We have 2 aqua ligands, so we'll have diaqua. We have 4 cyanidal ligands, so tetracyanidal. and then we have the iron. Overall, the square bracket part is negatively charged, which means we need to use the Latin name, which is ferrate. We then need to put the charge of the metal, which is 2+, in square brackets after. So overall, the name of this compound would be potassium diaqua tetracyanidopherrate 2. As before, we need to calculate the charge of the square brackets first. We have one chloride counter ion, which is one negative, which means overall the square brackets must be one positive. Amine ligands have no charge, but chloride ligands have a charge of 1 minus each, and there's 2 of them, so that's 2 minus. This means that overall the cobalt must be 3 positive charged to bring the square brackets up to 1 positive. We have 2 different sets of ligands here, and we need to name them in alphabetical order. Amine comes before chlorido, so we'll be naming that one first. We have 4, so we have tetraamine, being careful with spelling. We have 2 chlorido ions, so dichlorido. The square bracket part is positive, so we can just put in cobalt. We then need to put in the charge of the cobalt, which is 3, followed by the counter ion, which is chloride. So overall, we have tetraamine, dichlorido, cobalt 3 chloride. In this example, we have a 2 positive ion, magnesium, as the counter ion. This means that the square brackets must be 2 minus. The carbonyl ligands have no charge, whereas bromido ligands have a 1 minus charge each. There are 3, so that's 3 minus. This means that each of the platinums there must be 1 positively charged. So we name the positive ion first, which is magnesium. Then we need to look at the ligands. We have bromido ligands and carbonyl ligands. We need to name these in alphabetical order. So we have tribromido followed by tricarbonyl. We then have platinum. Overall, the square bracket part is negative, so we need to put 8 on the end. So we have platinate, followed by the charge of the platinum, which is 1. Overall, this would be magnesium, tribromido, tricarbonyl, platinate 1. In this example, we have nitrate ions as our counter ions, and we have 3 of them, which is 3 minus overall. This means that the square brackets must be 3 positive, and we have 2 neutral ligands, amine and aqua. Therefore, the 3 positive comes from the chromium. We have 5 amine ligands, so that will be pentaamine, followed by aqua, followed by chromium, as the square bracket part is positive. We can then put in the charge of the chromium, which is 3, and then nitrate to finish the name. When we're writing the formulae, there are some slightly different rules to follow. For the complex ion part, the metal comes first in the formula. The ligands come next, separated with brackets if needed. You order the ligands alphabetically by the coordinating atom, and negative ligands come before neutral ligands. You then add square brackets around the complex part, and then calculate the charge using the oxidation states, and show this outside the square brackets only if it's an ion. If counter ions are named, then you need to use the charge of the complex to work out how many of those you need, and add them to the correct side of the complex ion. You should always have your positive ion, the cation, first, followed by the anion, the negative ion. So here we have amine, tetraaqua, chromium 2, and we're looking at just the ion. The first part of the formula is always the metal, which in this case is chromium. We then need to put the ligands in, and they need to go alphabetically by the atom which joins. The atom which joins from an amine is the nitrogen, and from the aqua is an oxygen. Therefore, the amine must come first. So we have NH3, and we have 4 aqua ligands, so we need to put brackets around and put the 4 on the outside. We can then put the square brackets on, and as we're just looking at the ion, we can put in the charge. Chromium is 2 positive as a charge. The amines have no charge, and neither do the aqua. Therefore, the overall charge on this ion is 2 positive. Pause the video now and try these examples. In this first example, we have amine, we have pentachlorido, cuprate 2, and again we're just showing the ion. The first thing we need to write down is the metal symbol, which is Cu for copper. We've then got amine, which joins through a nitrogen, and we've got chlorido, which is a Cl. Chlorido are negatively charged ions, so they need to go before the neutral ions. Therefore, the Cl5 will come first, followed by the NH3. We can then put in the square brackets and start looking at the charge. The copper has a 2 plus charge. We have a 5 minus from the 5 chlorido ions and no charge from the amine ligand. This means that overall we have a 3 minus charge on this ion. Here we have silver 1, tetraiodido, mercurate 2. The first thing we need to do is to find the symbol for the transition metal, which is Hg. We then have tetraiodido ligands, so we've got 4 iodido ligands joined on, and we can put the square brackets round. The mercury has a 2 positive charge, and each of the iodido ligands has a 1 minus charge, so 4 minus overall. This means that the square brackets has a 2 minus charge. The silver has a 1 positive charge. Therefore, we need to have 2 silver ions to balance the charge, so it'll be Ag2. In this example, we have pentaamine, chlorido, cobalt 3, sulfate. The symbol for the transition metal is Co. We then have 2 ligands. We have a neutral amine ligand, which bonds through a nitrogen atom, and a negative chlorido ligand, which bonds through a Cl. Negative ligands come first, so we have Cl, followed by 5 NH3 ligands, and then we can put in the square brackets. The cobalt itself has a 3 positive charge, and the chlorido ligand has a 1 negative. There is no charge on the amine ligands. This means overall the square brackets has a 2 positive charge. This means we need just 1 sulfate ion to balance the charge. Here we have potassium, diaqua, tetracyanide, ferrate 3. For iron, we have a symbol of Fe, and then we have 2 ligands, a neutral ligand bonding through an oxygen, and a negative ligand bonding through a carbon. The cyanidal ligands are negative, so we'll go first, and we have 4 of those. We then have 2 aqua ligands, and then we can put in the square brackets. The iron has a 3 positive charge. Each of the cyanidal ligands has a 1 negative charge, so that's 4 negative overall, and no charge from the aqua. This means that overall the square brackets has a charge of 1 negative. We only need 1 potassium positive ion to balance the charge. In this example, we have 3 ligands. We have dicarbonyl, difluorido, dihydroxido, chromium 6, and we're just looking at an ion. The symbol for chromium is Cr. We then have 3 different types of ligand. So we have our carbonyl ligand, which is neutral, a fluorido ligand, which is negative, a hydroxido ligand, which is negative. So we need to put the fluorido and hydroxido ligands first, and they need to go in alphabetical order. So we'll have fluorido first, and we have 2. Then we'll have hydroxido, and again we have 2, followed by carbonyl, and again we have 2. We can then put in the square brackets and work out the charge to put on the outside. Chromium here is 6 positive, fluoride is 2 negative, the hydroxidos are 2 negative, and there is no charge from the carbonyl. This means overall the charge of the square brackets is 2 positive. Pause the video now and try to match each term to its definition. A complex is the name given when a ligand bonds to a metal through dative covalent bonds. A ligand is an atom or molecule with a negative charge or lone pair that it can use to form a dative covalent bond with a transition metal. A dative covalent bond is one in which both of the shared electrons are from one atom. The coordination number is how many bonds a transition metal has in a complex, and a bidentate ligand is one which can bond through two atoms. Thank you for watching my video. I hope that you found it helpful. Please remember to subscribe if you've not already and ring the bell to be notified of new videos. You can also follow me on Twitter at MissAdamsChem and Instagram Miss Adams Chemistry for updates throughout the year and flashcards. Bye for now.